finally the final part of this whole circuit. We explain actually the circuit should be looking more simple now, so let's make it more simpler. These are all gone. What am I doing here? This should be cut off, and let's just take that guy off. There's no reason. I mean, I should have edges coming out when I don't need to have one. Right. So now in the previous one we explained what is that creature's name in Lord of the Rings? Gollum. Yeah. We shall teach you. We shall teach you what we explained before. Anyway, that went off to the Egyptian accent. Hang back. In the previous one, I explained, or I was telling that I need some exact voltage around something at 0.14, 0.7 to 172. How much that makes? 0.14, I guess. 1.4, I think 1.4 voltage. 1.4 voltage to turn this transistor on. So I'm gonna be supplying 1.4 voltage from this side, right? Right, so this is how you make it down. Pretty weird brush. So 1.4 voltage is coming from, let's just say this circuit, this lovely circuit we have, right? Unknown circuit. We don't care. But what does this circuit do is that it gives me 1.4 voltage to here, and we know when that happens in any transistor, I mean, it has a circle outside or not, I don't care, but as long as a transistor is simply meant to turn, close or open a circuit. So obviously when I am providing voltage to this transistor, it is turned on, and what happens is that I have a circuit, sorry about that, a little bit fatty. Yeah. So as the circuit should look like this, and now I have to get rid of all the rubbishes. Yep, there we go. So pretty much I'm gonna come to this later on as well. I don't know. Actually, let's keep it here. Let's not make it too simple. So what's left right now? At the end, all this thing was to turn the LED on. I don't understand why all this pain. If they only wanted to just turn the LED on, they could just have a switch over here. They could provide the voltage here, and the LED would turn on. I don't know why there was the reason to give two different transistors. I don't know. Probably the signal I now explaining is that very low, too much low. And I don't see even probably it was, as I was trying to explain, it is in the middle. I was just guessing, but I think it's probably because in that way it makes sense that my input is so low. I mean, I cannot turn the infrared LED on. Infrared LED needs higher. In fact, needs around a range of 5 to 9 volts. Something actually not exactly 5 to 9 volts. It will be like around 2-3 volt, whatever it is. It does require some voltage. Okay, so the current, as I've been, in our practice, I've been doing that. What's going to happen is that current is going to flow from here. I don't know why I do that. Just a straight line. Right, so that's how the current will flow. That's my current. Right. Why don't you? Yeah, looks like more like the notebook annotations. So my current is gonna flow, and this will make this guy. You know what I'm saying? This guy. this guy. Yes, if you have noticed here, the third and the fourth marker should tell you. It will turn the LED on, the infrared LED on. So when that turns on, my circuit is working, right? That was the whole point of the circuit. I need to turn on I need to, turn on LED, right? Why this capacitor? Why? I mean, probably there was some capacitors lying spare, right? So, and if you don't make use of it, it will get rust. Somebody will steal it. So why not just use? No, I think obviously, whenever I use capacitor or my friend ever used capacitor, it was always because they need to stabilize something. Like I think stabilizing something, like like we don't want it to suddenly drop to really low voltage. Probably there is a chance that this our supply voltage could have some sudden drops or sudden high. Could be because our signal is an AC signal, right? So we don't want that sudden changes, right? So the sudden changes, I think, the word here we're looking for is I think yes, it is sudden. Sudden, it can't be just yellow all the time. Sudden changes. Sudden changes. We don't want sudden drops, or sudden drops, or you can say rise of current, sudden drop, and rise of current, right? So we don't want. So it is used to avoid sudden, or you can say yes, drops and change, rise of current, right? Or simply just say change of current, right? Changes of current. So yeah, so that's where the capacitor is working here. This is the only reason, and this is the only reason I can think of, and well, I'm getting better at marking, I guess. Not you, brush. So there you go. That's the reason, to avoid sudden changes in current. So that my LED will be affected by that, right? So that will be all. Let's not prolong it anymore.